Good morning, everybody. Last time we have to explain Snell's law, total internal reflection, law of reflection, and so on. So today I am going to start optical fiber. So in optical fiber depends on the principle of total internal reflection. And in the total internal reflection, only reflection takes place. In case of optical fiber, the monochromatic light incident on the interface between first medium and second medium. And angle of incident is greater than angle of critical. So here is no refraction takes place. Only reflection takes place. Refractive index of the first medium is greater than refractive index of second medium. That is mu1 greater than mu2. And incident angle is greater than critical angle. That is angle of incident I greater than theta c. So, in case of total internal reflection, if the angle of incident is greater than critical angle and no refraction takes place, only reflection takes place, it's called total internal reflection. And here is two conditions, that is mu1 greater than mu2, that is first refractive index is greater than second refractive index. Second condition, angle of incident is greater than angle of critical, that critical angle denoted by theta c. This is the diagram of optical fiber. The optical fiber consists of outer jacket, strength member, internal coating and fiber. This is the structural diagram of fiber or optical fiber. Keep in your mind. This optical fiber communicates core, cladding and protective skin, or optical fiber consists of three main parts. That is, first one core, second cladding, and third protective skin. In first step, core, also known as fiber, cladding, also known as inner coating, and protective skin, also known as outer jacket. These three main parts or fiber optics consist of three main parameters: core, cladding and protective skin. So first I will explain core. Core is the first part of the optical fiber. It is an innermost layer. The length of the fiber optics is 1 meter. The refractive index of core is greater than refractive index of cladding. The refractive index of core is 1.48 and the inner diameter of the core is 5 micrometer to 600 micrometer and outer diameter of the core is 0.1 mm to 0.15 mm. Keeping your mind. This is very important for your view of examination. Again I repeated this core. Core is the first part of the optical fiber. It is an innermost layer. The length of the fiber optics is 1 meter as like a hair-like structure. Optical fiber is a hair-like structure. The refractive index of ore is greater than the refractive index of cladding. And the refractive index of ore is 1.48. Refractive index of ore is 1.48. There is no unit because the refractive index is unitless quantity, that is constant. Inner diameter of the core is 5 micrometer to 600 micrometer. That very small diameter. And outer diameter of the core is 0.1 mm to 0.15 mm. 0.1 mm to 0.15 mm. Now cladding. Cladding is the second part of the optical fiber. Already we have to know in the fiber there are three parts: ore, cladding and protective skin. So second part of the optical fiber is cladding. This layer is sufficiently thick. It has minimum thickness. The refractive index of cladding is 1.46. Keep in your mind. The refractive index of cladding is 1.46 and diameter of cladding is 1 to 5 micrometer to 750 micrometer. 125 micrometer, 125 micrometer to 750 micrometer. Cladding is covered by a buffer plastic. Cladding is covered by a buffer plastic. It gives the strength and safety. The more use of cladding gives the strength and safety. So refractive index of cladding is 1.46 and diameter of the cladding is 1 to 5, 125 micrometer to 750 micrometer. This cladding is covered by the buffer plastic and it gives the strength and safety. So in the optical fiber there is two main conditions that depend on the internal reflection. In total internal reflection, only reflection takes place, not refraction. So first condition is mu1 greater than mu2, that is first refractive index is greater than second refractive index, and I greater than theta c, or angle of incident is greater than angle of critical. This is the two condition of total internal reflection, and the optical fiber is depends on these two conditions because the optical fiber works on the principle of total internal reflection, that is TIR, total internal reflection. When the monochromatic light is incident on the interface between optical medium or optical denser medium and rear medium, if angle of incident is greater than angle of critical, angle of incident is greater than angle of critical. So this is the important points or important condition in the optical fiber. Optical fiber is a hair-like structure. Optical fiber is a hair-like structure which communication or which depends on the three main parameters, three main parts of the optical fiber. Number one, ore, second cladding, and third protective skin. So here is diameter of the core is 1.48. This is the refractive index of the core. and inner diameter of the core is 5 micrometer to 600 micrometer, and outer diameter of the core is 0.1 mm to 0.15 mm. Second point, this core, the light is transmitted within the core. In the core, light is transmitted within the core. The core is innermost layer. The core is innermost layer. Second point, cladding. The cladding keeps the light waves. Cladding keeps the light waves within the core because the refractive index of the cladding material is less than that of the core. Cladding material is less than that of the core. Cladding acts like a reflector and keeps the light within the core based on the total internal reflection. The cladding also provides some strength to the core with a bunch of optical fiber is packed in one cable. The cladding layer avoids the interface between light rays in the adjacent fiber. Cladding provides some strength to the core. When bunch of optical fiber is packed in one cable, the cladding layer avoids the interface between light rays in the adjacent fiber, and therefore the cladding is the second part of the optical fiber. This layer is sufficiently thick. The refractive index of cladding is 1.46. The diameter of the cladding is 125 or 125 micrometer to 750 micrometer. Cladding is covered by the buffer plastic and it gives the strength and safety. So this is the explanation for cladding and core. And last part of this optical fiber is protective skin. So student, this protective skin I have to explain later on. So today I stop here. Thank you very much.